Another type of access control is extended ACL. This one allows to filter more parameter in IP packet, as such is more versatile and much more often used. So the best way to do this is just by looking at a certain example. And just like a standard ACL can be used for many things, not just packet filtering, can be used to create VPNs or maybe do complex NAT or debugging of IP packets if need be. But in this particular situation, what I'm going to do as a packet filtering is to use extended ACL to block the traffic from this cloud to, let's pretend that PC2 is a server, but I'm not going to block the whole traffic, but to specific ports. So for example, I'm going to enable port 80, which will be allowed, pinging will be allowed from the source of this EIGRP cloud towards that server, but telnet should not be allowed. So obviously standard ACL cannot be used because it only matches traffic on the source IP address, single parameter in IP packet. I cannot use ports at the layer 4 with standard ACL. This is where extended ACL comes in handy. So let's look at this anatomy. So what I'm going to do is, first of all, I'm going to plan my action. So I know that this source is any source from coming from this network, any source, going to specific host, which is going to be 10.1.2.102, and I'm going to block specific traffic for telnet. Everything else should be allowed. So this is my criteria. Now, where would I place this extended ACL? Would it be on, let's say, R3 or R4 or maybe R6? Since this is extended and we already know where the packet is coming from and where it is going to, we can place the extended ACL closer to the source, unlike the standard ACL, which we had to place closer to the destination. So I'm not going to be doing this. I'm going to be putting this as close to the source as possible. So that will be interface Ethernet 0/3.30. But first, let's see what was working. So what I'm going to do is I'm going to enable on PC2 HTTP service. So let's go to PC2. It's enabled already. So I basically did this command, IP HTTP server, and now server is enabled here. I could enable a 443 port as well, but it's no point. This one will do just for the demonstration purposes. So at this point, I should be able to ping 10.1 to 102. I can. I should be able to telnet to port 23, 10.1 to 102. And this is the one I'm going to be blocking. Now it's allowed. And finally, the same thing for port 80. And the connection gets open. So that should be allowed as well. So let's stop it by doing get and clearing my terminal. So let's look at the R6. So I'm going to be creating access control list on R6 and placing this as packet filtering on Ethernet 0/3.30. So, okay, global config mode first, and the command will be access list, and this is where the number 100 through 19 comes into play. Extended access list right here. I'm going to say 100, first number available, and question mark. So what it is asking, again, like previously, is this going to be deny or permit traffic? Dynamic access controllers is a different breed of access controllers, which are not very often used these days. Remark is the description. So I'm going to say deny traffic, because I want to deny traffic from any source coming from here on this interface. So this is where my question mark again shows me what I can do. I can use IP protocol number if I know what the layer 4 protocol number is going to be, or I can use basically keyword here for protocol such as EIGRP, TCP, ICMP, and so on and so forth. So each of these protocols have also their protocol numbers. For example, OSPF is port 89. So I'm going to be doing this is a telnet, so it uses TCP protocol. So what follows the deny or permit statement is the type of protocol. I'm going to say TCP and do a question mark. So now it is asking me for source IP address. If I know what that source IP address is, I can place it with a wildcard mask. So this could be whole subnet, for example, 10.1.30. So I could say if I wanted to block the whole traffic from this subnet, it would be 10.1.30 0, and the mask or wildcard mask it would be this. But I don't want to do that because there are more than just this subnet here. There's more networks in this ERGRP cloud. So I want to list them all with the keyword any. So I'll say any network. Now what follows is I can use the source port number for TCP if I know what that one is. Since this is the client initiated session here on the right hand side, I never know what the port is going to be because it's always this a range of ephemeral ports, which means above 1023. I don't know what that port is going to be. It could be 50,000, could be 1078. So I'm going to skip that section and I'm going to proceed to the destination. So one of the parameters is destination address. Now I know exactly what the destination IP is. It's PC2. So I will say host 10.1.2.102. Alternatively, I could say without the host keyword 10.1.2.102 with a wildcard mask 0.0.0.0. But that is probably easier to type in, maybe a little bit shorter. What follows is the destination port number. Now that one I do know because the client always initiates telnet session towards the destination port TCP equal 23. So this is where those parameters come into play. Equal or less than ports. I can have a range of ports. I could have a greater than ports. I'll say equal to exactly 23, or I can use the keyword telnet. So if I do question mark, I can see what the aliases are for ports, and telnet is listed here as port 23. So I can say, you know what, let me do telnet. And again, like previously, access control list is a top-down process. If there's a match, the remaining entries are ignored. If there is no match, there is a implicit deny everything else at the end. So at this point, if I apply that, everything would stop because there's nothing permitted. So I'm going to go again, create at least one permit statement for the same ACL. And here there's a gotcha. I don't want to just enable TCP from any source to any destination. I want to enable any packets because I'll be sending pinging and stuff like that. So I'll say permit IP protocol. IP encapsulates TCP, UDP, ICMP, IGMP, and so on, from any source to any destination. I'm not specific here, so this is just for blocking telnet access, and these two statements are going to do that. They are going to block telnet from any source to destination particular host, port 23 destination, and permit everything else. Now obviously this is not working yet because I haven't applied it, so I need to apply this on this E0.3.30 interface. So interface E0.3.30 with IP access group 100 inbound, because the packets are going to be coming in and going out that interface towards that PC. So if I apply that, what I should work now is ping 10.1.2.102, and it works. What should work is port 80, so I should go for, let's say, control A, maybe telnet, and port 80. That should work, and it's open. But if I try to do telnet, it should refuse. So control 6X and telnet port 23, and destination unreachable. And like previously, modification of access list, maybe I want to log this entry. So I can use either IP access list command, which I will use in the next video, or I can use basically Notepad. And maybe if I just go ahead and see what this is, so do show run include access list 100, I can copy them. So one way of changing, rearranging, modifying ACL would be text editor maybe, and I can say I will say no access list 100 this way, and then add this log statement, right, just like that. So first I'm removing ACL, but it's still applied on the interface. By the way, if I remove ACL and I have IP access group on the interface, the IP access group does nothing. It's just sitting there waiting for actual statements. So now what I'm gonna do is I'm gonna apply that, and now I'm logging those attempts. So if I repeat my telnet to port 23, I get the same message, but this time around I should see, and I do, this log entry. So one packet is always logged in from that particular source, and we blocked from port 29146. I didn't know what the source port would be, but I did know what the destination port would be, 23, and that's being effectively blocked.